So here we have a quadratic equation. We're asked to find the range of values for p such that when we solve this quadratic equation we get no real roots, there's no real solutions. So let's talk for a wee minute about quadratic equations and roots. If we have a quadratic expression, and generally x squared plus bx plus c for instance, and we graph the values of this expression as heights on a graph, then we'll end up getting some form of parabola. It might be this way round, it might be inverted. If we're asking when, or asking for values of x where the value of this expression is 0, then we're looking at x values here. There's where the height of the graph is 0. We're looking for intersections of this graph with the x-axis, and that's where we'll find the roots of this equation. So there's several things that can happen. As in this example, we could get 2 if the parabola just came down and touched the x-axis. We would get 1 root, or it might not come down far enough to touch the x-axis, and therefore there would be no values of x, there would be no real roots, which is the situation that we're actually wanting. Now, it is possible to find these values of x by solving this quadratic equation, and there is the well-known formula that is minus b plus or minus square root of b squared minus 4ac all over 2a. That's the good old quadratic formula. So it does, on the face of it, look like it gives us 2 solutions to that equation, 2 roots. However, when we look at what we're adding and subtracting, it's the square root of b squared minus 4ac. And if b squared minus 4ac is greater than 0, if it's a number greater than 0, then we will be adding and subtracting a positive number, so producing 2 solutions. However, if b squared minus 4ac is equal to 0, then we're adding 0 and subtracting 0. We'll only get 1 root. So this had 2 roots, and this situation had 1 root. And indeed, if we've got a number under that square root sign that's less than 0, square root of a negative number will not give you a real answer, so there will be no real roots. And that's the case when b squared minus 4ac is less than 0. So in the case of this equation, x squared minus 2x plus 3 minus p equals 0, let's compare it with the ax squared plus bx plus c equals 0. And you can see that in this case, a is 1, the coefficient of x squared is 1, the 1 there. B is equal to negative 2, coefficient of x is negative 2, and the constant term is 3 minus p. So c is 3 minus p. So the discriminant, that's the number that appears under this square root sign in the quadratic formula, b squared minus 4ac, in the case of this quadratic equation, is negative 2 squared minus 4 times 1 times 3 minus p. Negative 2 squared is positive 4. Negative 2 times negative 2 is positive 4. This comes to minus 4 outside this bracket, so we can get rid of the brackets. Minus 4 times 3 is minus 12, and minus 4 times negative p is positive 4p. So we're ending up with negative 8 plus 4p. Or a normal way of writing that would be positive 4p and a negative 8. Positive 4p, negative 8. You couldn't write it the other way around. 4p minus 8. So that's the discriminant. And since this is the situation we're after, where we're wanting the graph, if you like, to miss the x-axis, to have no real roots, that'll only happen if the discriminant's less than 0. For no real roots, we require discriminant less than 0. So 4p minus 8 would have to be less than 0. Now add 8 to both sides, divide both sides by 4. 4 into 8 goes 2. So it has no real roots if p is less than 2.